My name is Brandon Forbes. I'm a hydrologist in Tucson, Arizona.
My name's Chris Smith. I'm the data chief for the Arizona Water Science Center.
Today we're at Altar Wash, which is an ephemeral stream in southern Arizona, and we're surveying with the ground-based LiDAR so we could get a full 3D scan or full 3D topography of the channel behind us. What we're doing now is we're collecting topography data. We're going to plug that into the 2D model, and that's going to tell us where we should deploy our stage sensors in this reach behind me. Once we have that deployed, then we're ready for monsoon season, which usually is going to start about mid-July. So once that's in place, the mousetrap's set, and we hope to have some flows and then get our scientists out to make direct measurements, and then we'll have the full suite of data to really calibrate this model and see how well this process is going to work.
One problem that we have in Arizona, especially a gauge like this, is that we may not have a flood for 3 to 4 years, maybe even 10 years. And in between the floods, we have this vegetation build up in the channels.
And one of the things we look at is vegetation that's well established. This is a small stand of desert broom. It's on the right bank, just downstream of the gauge. And you can see it's woody vegetation, but it has the ability to be laid over. When you have vegetation like this, it provides resistance to the flow. And what that does is it raises the stage for the same amount of discharge and lowers the velocity. So it's a key part of calibrating a 2D flow model, is determining what this roughness and what this resistance actually provides to the flow. We're back in the office after the field campaign, and we have a point cloud made up of over 12 million points that we can now process in the computer and use as a tool to decide where to put the stage sensors. Here we are in the point cloud. We're located just underneath the bridge. Our stream gauge is located here on the left bank. And what we can do is we can visually zoom in, decide what kind of vegetation we want to avoid and what kind of banks we would like to mount the sensors in. This is a visual tool. We'll then plug this point cloud into the 2D flow model, and that will give us a hint as to what velocities are in the channel and at what places we can get the best representation of what the water surface would be in a flood.
We're back at Altar Wash. We came out with a crew, and we're going to install the posts that hold the CSA sensors. And so we just got done pounding these posts in. We'll come out here next, and we'll go and install the sensor itself. There'll be a little housing for the sensor, and we'll bolt it to these. When you put a gauging station out, you want an accurate rating curve. You want it to measure the flow as accurate as possible, because people are making decisions on that data. You know, sometimes it's operating a reservoir, sometimes it's a road closure, sometimes it's evacuating people. So the higher the accuracy for the gauge, the better decisions that'll be made. If this experiment is successful, we'll have a more accurate gauging station. And if we can make it work here, we can expand it to other gauging stations in Arizona. So this is something that will really help us to better understand what the flows are actually happening during a flood.
To be able to collect these different types of data, especially stage at many different locations, and in turn calibrate discharge at many different water depths as we're going to try to do here, it just allows us to have a much more robust understanding of what happens at our sites. And when floods are occurring, the data that we serve to the public and to watershed managers and emergency managers will be that much more accurate. And all that does at the end of the day is it keeps people safe and it keeps people out of harm's way, and that's really what we want to do.